All right, let's make sure we are recording. Perfect. Okay, so today I'm covering horizontal and vertical lines. So in order to kind of understand these, we need to kind of have some background information. So we're focusing this week on linear equations in two variables. So we have x and y. And we have an equation that allows us to graph a line. It's ax plus by equals c. So A, B, and C are just numbers. A and B are not allowed to be, they can't both be zero because then you have zero equals a number, which doesn't mean anything. When you've got your X and Y on the same side, that's called standard form. And generally we're plugging numbers into X and solving for Y, but when it's in the form where they're on the same side, you can plug numbers into either one. There are two additional equations for lines. We've got y equals mx plus b, and then y minus y1 equals m times x minus x1. So these equations are used to graph lines. We're talking about horizontal and vertical lines here, so obviously the equations for those types of lines are going to be related to these. Now, another important concept are intercepts. And so these are the locations where your graph crosses your x or y axis. So if it crosses the x-axis, it's an x-intercept. If it crosses the y-axis, it's a y-intercept. And these are also important and related to horizontal lines and vertical lines because they have intercepts. So for your x-intercept, your y value is 0 because it's not crossing the y, it's not going vertical at all. So your ordered pair has 0 for your y value. The y-intercept is not going horizontal, so your x is equal to 0, and then your ordered pair only has a y value because your x is 0. So these are important concepts and they do relate to horizontal and vertical lines. So we've got these two special types of linear equations, the horizontal line and the vertical line. So for horizontal lines, and just in case you do not recall, those are going straight left and right. Your equation is the form y equals a number. And this is because when you graph it, it's only going through the y. So if you have your grid, it's only going through the y-axis, so there's only a y-intercept, and your equation is in the form y equals. There is a special case if it goes exactly on your horizontal axis, but where you have infinite x-intercepts essentially, but there's only a y-intercept, it doesn't cross the x. Then we've got the vertical line. So again, if I just graph my x and y axis, the vertical goes up and down. And so it is only hitting the x. So there is only an x-intercept. There is no y-intercept. And so the equation is the form x equals a number. So basically, wherever your intercept is, that gives you the equation of your line, whether it's a y equals for horizontal or x equals for vertical. So when you're trying to think about your equations, think about where am I crossing? Am I crossing the y or am I crossing the x? And that will give you your equation. So we will start with just some true false examples here. And then if it's false, we're going to fix it to be true. So the line defined by x equals 3 is horizontal. So if you think about x equals 3, if I've got my axis, actually I'm going to move this over to the right so I can make corrections if I need to. So I've got my x and y. If I have x equals 3, that would be right here. Now, a horizontal or vertical line, it only goes through one axis. So that means I have to have a vertical line here. So this is not horizontal. This is false. This is vertical. And the next one, the line defined by y equals -4 is horizontal. So if I graph x and y, if we have y equals -4, that's going to be somewhere down here. So if I draw a straight line, I'm just hitting the y a billion times. That's not right. It only goes through one. So this is going to be a horizontal line. And so this is true. Next, we've got a line parallel to the y-axis is vertical. So again, these are always very helpful to draw your x and y axis so that you can visualize these. And so if I am parallel, that means I'm going to be the same direction and slant. And so that means I'm also going to be a vertical line because the y-axis is a vertical. So this is true. And then this last one, we have a line parallel to the x-axis is horizontal. So I'm going to label my x and y. And if I'm parallel to the x, then I need to have the same shape and direction. So that means the x is horizontal. So my parallel line is also going to be horizontal. So that is true. So the only one here that was false was the first one. And x equals gives us a vertical line, not a horizontal. So we're going to do some graphing of these lines. So we're going to start by plotting points. So let's say you have a table and you need to fill in the table to graph this line. And your equation is y equals 3. So on our table, we're given x values. X equals 2, 0, and -1. Well, there's no x to plug into. Our equation just is y equals 3. So y is always 3 because it doesn't matter what x is. X is not in the equation. So all of these are going to have a y value of 3. So I can just kind of plug those in. So now I'm going to plot those points. So an x of 2 and a y of 3. Puts this right there. X of 0, y equals 3. And then -1 and 3. So, I'm not perfect here when I'm drawing my dots, but especially that first one was very off. Let's see if I can fix that. But if you connect these, you see that it forms a horizontal line. So everywhere along that y line, the y is equal to 3. And that's, if you see a y equals equation, there's no x involved. There's only one variable. And that's the key. If there's only one variable, either x or y, it's going to be either horizontal or vertical. The only time it's slanted is if it has both letters in it. So if I have only one letter, it's going to be one or the other. And for y, you think, well, y is 3 everywhere on that line. So that gives us a horizontal line. So same thing here, we're going to graph by plotting points, and we're given the equation x equals -4. So we don't have a y value, so this tells us it's going to be a horizontal or vertical. And if you look at the table, we have y values of 1, -2, and 4. But there's no y in the equation to plug in. All we know is that x is -4. So I can just fill that in for every single point here. It doesn't matter what y is. X is -4. That's what the equation says. So I'm going to now try to graph these as best I can without messing up. So I've got -4, 1. We've got -4, -2, and then -4, 4. Right there. And so when you connect these, you are going to get a vertical line. Everywhere on that line, and of course, I'm not very good at drawing vertical lines. You can see it doesn't really go through the grid, but in a perfect world, everywhere on that line, x is equal to 4. That's why the equation is x equals 4, because that's what is true along that line. So here we have x equals 3. So we need to first identify whether this is horizontal or vertical. So x equals 3 think about your X is a horizontal line, your X axis is horizontal. So I think of it as, okay, this must be a vertical line. I kind of think about, you know, it's sort of the opposite. If your equation has X and your X axis is vertical, then the line is, or your X axis is horizontal, your line is going to be vertical. This may be confusing for some people. So you can also say, okay, where is X equals 3? Now I'm not going to match the axis. I have to go perpendicular to the axis, do the opposite. So that's going to be vertical. So when you graph it, you just graph that location X equals 3, and then you draw a vertical line through that point as best as you can. Now, X and Y-intercepts. We are not crossing the Y-axis at all. So there is no X-intercept. I mean, no Y-intercept. Okay, man, today I'm really going backwards, guys. It doesn't cross the Y-axis at all. There's no Y-intercept, but there is an X-intercept. And that is at X equals 3. Or sometimes as an order pair, we would write this as 3, 0. So your equation is X equals 3. That is literally what your X-intercept is. X equals 3. Okay, here we have the equation negative 2y equals 8. So it's not a y equals or x equals like our other ones, but think about, okay, whatever letter they gave us, y is a vertical line. So this is actually going to graph the opposite. This is going to graph a horizontal line. That's how I think about it. So whatever the letter is that they give us, and then I look at the axis, y axis is vertical. So this graphs a horizontal. So in order to graph the line, we actually want to solve the equation for y. So I need to divide both sides by -2. And that gives me y is equal to -4. So I'm going to put that on my graph, and now I know it's going to be horizontal. So I'm going to do my best to draw a horizontal line through y equals -4. So in this case, we never cross the x-axis, so we have no x-intercept. But we do have a y-intercept at y equals -4, or the ordered pair would be 0, -4, because it doesn't go through the x, so that's at 0, and then the y is at -4. Okay, x minus 3 equals -7. So the only variable we have is x. The x-axis is horizontal, which means this graph is going to be vertical. So I identify the variable, what axis it goes with, and then whether the axis is horizontal or vertical, and then I do the opposite. So this is going to give us a vertical line. So just like the other example, we have to solve for x in order to graph this. So we've got x minus 3 equals -7. So you add 3 to both sides, and you get x is equal to -4. So I'm going to go to -4 on the x. I should have picked different numbers since I seem to be graphing the same numbers over and over again. But it's going to be a vertical line through x equals -4. So we do have an x-intercept, and that is x equals -4. Or as an ordered pair, that is -4, 0. So it's not going anywhere on the 0 on the y. And there is no y-intercept because we are not crossing that axis at all. All right, so here, 3y equals 0. So our variable is y. Y-axis is vertical. The opposite of that would be horizontal. This is a horizontal line. So to graph this, we have to solve that equation for y. So with 3y equals 0. And so we're going to divide both sides by 3 because we just want to have y. And that gives us y is equal to 0. 0 divided by 3 is 0. So when y is 0, we're right here. And so you're like, okay, you can't just say, okay, I do the opposite, is it vertical or horizontal? This is where you have to say, okay, what we did is we determined a y equals, that's a horizontal line. So it is literally on top of the x-axis here. So we actually have infinite x-intercepts because it's touching every place on the x. So I'm going to just write infinite x-intercepts. We're not going to even bother trying to write all of them because you can't. There's infinite many. But we do have one y-intercept. And that is y equals 0. And the ordered pair is actually the origin because our x is 0. And so it's literally at 0, 0. But this is a horizontal line. Y equals is always going to be a horizontal line. Okay, 2x plus 7 equals 10. So our variable is x. The x-axis is horizontal. So this graph is going to be vertical. So now we want to graph the line. So we need to solve the equation for x. So I'm going to first subtract 7 from both sides. We got 2x equals 3. And then we need to divide both sides by 2. We get x is equal to 3 halves. So 3 halves is the same as 1.5. So that puts us right there. And this is a vertical line. So I'm just going to really badly draw a vertical line here. Really bad at those vertical lines. Our x and y intercept. So we have an x-intercept at 3 halves. Which is an ordered pair is 3 half comma 0. And we have no y-intercept because we're not crossing the y-axis. Okay, so now we're going to determine whether these equations have x-intercepts or y-intercepts. It's their same equations in each one. So if it has both x and y, it will have an x and a y-intercept. So the first equation, 2x minus 3y equals 6, has both an x and a y. It will have both intercepts. Any equation that has both x and y will have an x and a y-intercept. That's guaranteed. The next equation here is, and actually the bottom equation also has both x and y. So that's also going to have both x and y intercepts. So the remaining two, we have x equals 5. So if it's x equals, that's an x-intercept. And because there is no y in the equation, there is no y-intercept because it's not going to go through the y. The previous video that I have on finding intercepts, you find the intercept by plugging 0 into the other variable. And then you solve. So if we're trying to find a y-intercept, we make x 0 and then solve for y. But there's no y in the equation to solve for, so there's no y-intercept. The next equation, 2y equals 8. So This is going to be horizontal. You want to, be able to identify an x equals is vertical. Anything with y only is horizontal. And so there's no x-intercept because there's no x to solve for, but there is a y-intercept. So equation with y equals only has a y-intercept. Equation with x equals only has an x-intercept. The x is always a vertical line, so it doesn't go through the y. The y is a horizontal line, so that doesn't go through the x. So you can kind of, match the x and y intercepts. Those vertical and horizontal lines are special. Aside for one where it's on the axis, they only have one intercept. They don't have both, like if you have both x and y in your equation. So that's horizontal and vertical lines in a nutshell. It's really important to be able to recognize when an equation is horizontal or vertical, because you don't always get equations that are slanted. So you want to be able to recognize them and then understand what their intercepts are and what they look like when you graph them. So if you have any questions, just let me know. And I will see you guys at the next live.